Hey, if I ever forget to record, please, somebody in here remind me, all right? If I ever forget to record, please, somebody in here remind me, because then I got to do the whole thing over again. I don't want to do that. Okay, so let me go back real quick where I was. I traced the triangle, right? Oh, now we got a mess going. We'll get there. I'm still not even. I traced the triangle, right? And then I spun it, and I put it together, and that shape is a parallelogram. And again, say the formula for a parallelogram. Area of a parallelogram is? All right, don't do this. I mean, you can if you want. There's base. There's height. Agreed? So if we were going to figure out the formula for the whole parallelogram, it would be base times height, wouldn't it? It would be base times height. But in reality, we don't have this other triangle to flip, do we? But notice we still have a base. We still have a height. We don't have that area. We've got this area. So what's the formula for area of a triangle? Anybody raise your hand and tell me? Formula for area of a triangle? Area? Go for it, Adam. Take a shot, man. You might be wrong, and half the people don't know anyhow, but maybe you're right. Not base times height, but at least you went for it. Hey, sometimes you'll be right. I'd go for it. What's the formula for area of a triangle? Area of a triangle. Base times height would have been the whole, that would be base times height, the whole parallelogram, right? That's base times height. This is a 10 and this is a 4. The area of the parallelogram is 40 square units. We want, what in the world? All right, who knows? Come back, wherever you are. We want just the triangle. So the formula is, Kirsten. Say it again. That sounded better than your first attempt. Wouldn't you agree it's half the area of the parallelogram? It's exactly half. The formula is, I'm going to do this in red. 1/2. Then take your red and do your red for your base, and then take your green and do your green for height. That's the formula for area of a triangle. 1/2 base times height. And you can't forget the half. It's half of a parallelogram that would have the same base value and the same height value. Now, if you remember, the base and the height are key things. And that's what you got to keep straight. So remember, the height is always the perpendicular distance, but for a triangle, between the base and the opposite, and I'm going to do this in green, vertex. Every triangle really has 3 different sides, so it could have 3 different bases, and would also have, therefore, 3 different heights, depending upon which side you chose for your base. You got 3 sides to a triangle, so any of the 3 sides can be the base, and therefore then you have 3 different possibilities for the height. So here's the key. Choose the base according to whichever side the height is perpendicular to. Choose the base according to whichever side the height is perpendicular to. Remember the problem I just did for Wyatt from the homework? Remember how his problem was he chose the wrong side for the base according to the height? That's what will get you in triangles as well if you're not careful. Well, if you look at example 1, notice where the height is. Therefore, which side is going to be the base? Now, don't do anything yet. Just look at the left triangle. Is that the base? Is that the base? Or is that the base? So I'm going to say bottom, I'm going to say right, or I'm going to say left. Which one would you call the base? Bottom, right, or left? Are you ready? On three, give me your choice. Bottom, right, or left? Here we go. 1, 2, 3. Left. Great choice. Exactly right. It is the left, right? Because that's the side that we're given the height to. Any three sides can be the base. We just got to make sure we use the correct one for the given height. Okay, so again, we have bottom, right, left on the middle one, right? Which one's going to be the base? Bottom, right, or left on three? 1, 2, 3. Right. Exactly correct. The right is the base. And the third one is the way you normally want to think of the base, that it sits on the base, but it doesn't have to sit on the base, right? All three of those are possible. And so you just got to make sure you use the correct numbers and run your formula. If you do that, you'll be in good shape. Let's do some examples. All right, so C, find the area. Well, look, we got numbers for all three sides. Hey, how do we start any area problem? We start it with the formula. So I'm going to say area, and you can use TRI. I usually just do the triangle symbol, but whatever you want. Again, why the subscript? I'm trying to train my brain, right? I'm trying to associate my brain with a triangle area formula, not just every area formula. So you got to associate it with the shape. And we know, again, I'm going to use my red here for 1/2, the base, and then in green times the height. All right. Hey, I don't know about you, but 1/2 is 1/2. And I'm going to skip the base because we all know the height is not only just 3, but 3 inches, right? I'm always keeping my units there so I don't forget them. Now the only question is, what do I use for my base? Do I use the 4? Do I use the 9? Do I use the 13? Which do I use? I use the 13, of course. Awesome. All right, and that's 13 inches. Yes, that is the base, right, according to the height given. Does that make sense? Right? There are other heights, but they didn't give it to us. They only gave us the height that goes with the 13. Okay, this would be a calculator problem. How can you do 1/2 on your calculator? 2 different ways. Most of you would do, Pamela, 0.5. That's the easiest way. 0.5 times 13 times 3. So go ahead and get your calculators out. You should have them out every day in pre-algebra because we don't want to take the time to do menial math. Sometimes you'll be able to, it'll be a number that you can easily take 1/2 of. So what do we get? 1/2 of 39. So what is that? 19.5. What are my units? Inches squared. You got to use the IN. You can't do the symbol and put the square on the symbol, right? Gabe, question?
How'd you know it was inches?
Because of the symbols. That's an inch symbol, inch symbol, inch symbol. Okay, the lengths were given in inches. Okay, if you can't see it there, maybe you can see it better on your paper. Okay, so we were given it, and that's why we knew, only because we were given it. Good question. Anybody else? Jack? Feet is 1 slash is feet. 2 slashes inches, 1 slash is feet. Nick? You'll get a totally wrong answer. Not a different answer, a wrong answer. There's only one area for any given shape. But if you use the wrong sides, just like Wyatt did on that parallelogram, you're going to get the wrong area. You'll get a wrong area. Kirsten? You would put units squared if it didn't say inches or meters or whatever. Okay, let's find the area of this one. So again, how do we start? With the formula. Area of a triangle. Don't forget the 1/2, because it's 1/2 of a parallelogram. 1/2 base times height. All right. Usually once I write the area one time with the triangle, I don't write it the second time. You can if you want. Okay, in this one, don't say anything out loud. Because the only tricky part is figuring out what the base and the height are, right? Other than that, they're pretty easy problems. The formula's not that complicated. So we just got to make sure we use the correct 2 sides. To be honest with you, in this one, I couldn't tell you exactly which one is the base and which one is the height, but I can tell you which two are the base and the height, right? Because it doesn't matter which one. You could call one of them the base and the other the height, or the one you call the height the base and the other one the height. You just got to make sure you pick the right two. And again, how would you know? You would know by this fact. In your brain, hopefully you think the height is always perpendicular to the base. Therefore, for base and height, what two numbers would we use? On 3, tell me the two numbers. Right, you're going to say like 10 and 8, 10 and 6, 8 and 6, right? Those are the three possibilities. On 3, 1, 2, 3. 8 and 6. Or you can do 6 and 8. It doesn't really matter. But notice, that's what happens on a right triangle because those two sides are perpendicular, right? So now just finish that off. You don't even need to do 0.5. What's half of 8? What's 4 times 6? And don't forget your meters are now, your units are squared. Again, I always include my units because I'll know that millimeters times millimeters is millimeters squared, Jack. You have to use the point on this one is if you want to call that the base, this would be the height. If you want to call this the height, then this would be the base, but you're using the correct two sides. With a right triangle, Jack, it doesn't matter. It's because it was a right triangle. So if you look at the shape, you could easily want to say that it's sitting on the base. So most people like this would call this the base and that the height, right? However, if you just spin the triangle, what if it were like this? Oh, spin a little bit more. Then if you want, you can call this the base down here and that one the height, and they switch. It doesn't matter. As long as you have the two that are perpendicular, but that's for a right triangle. For a right triangle. Okay, E. Let's start with our formula. Why don't you guys try this one? See what you can do. Go ahead and figure out the area of that triangle. Dotted lines are not part of the triangle. They are lines that are added to help you understand values. We have an oblique triangle, an obtuse triangle. It's got an obtuse angle, right? Remember that from last chapter? So you got a big hint. Area equals 1/2 base times height. Is there no triangle for your next problem, F? Where did my triangle go? I have no idea. That's funny. Oh, brother. Yes, Corel Draw, my drawing program. All right, and something like this, 10 meters is indeed your base. It's showing the 6 meters perpendicular to that base to the opposite vertex. So this ends up being, what, 30 meters squared? How many got that correct? Again, you're looking at the relationship, right? You got to just use the correct base and the correct height. All right. I'm trusting that I wasn't supposed to waste time and do the next problem so I can get the trapezoids. All right, there's a picture of a trapezoid, right? Again, you got to know your shapes. Most of you guys did very well in your matching section of matching shapes. Some of you don't know that that's a trapezoid. You're going to have problems doing area. If you don't know the thing's a trapezoid, you're going to have trouble doing the formula if you don't even know it. So you got to be careful there. So a trapezoid is a quadrilateral with one pair of parallel opposite sides. And you can see the green sides are parallel. That is a trapezoid. So a trapezoid is a parallelogram, or is a quadrilateral with one pair of parallel opposite sides. Here is the formula. There's a couple different forms this can have. So it really does depend upon the publisher of the course. To me, the standard formula goes like this. We have a half again. And then we have in black a parentheses. The next thing in the parentheses is b with a subscript 1, b of 1. We then have a plus sign, b of 2. That's base 1 plus base 2. Base 1 plus base 2. And then finally, times h. And h, of course, would be the height. Oh, sneeze coming. Oh, excuse me. All right, couple keys. The bases are always the parallel sides. The bases are always the parallel sides. Always. So if you go to the trapezoid on the right, I'm going to go on the bottom and call it b of 1, base side 1, and go opposite it to the other parallel side and call it b of 2, base 2. Base 1 and base 2 are always the parallel sides. Height, we already learned, is always the perpendicular distance between the parallel sides on this one. Height is the perpendicular distance between the parallel sides. All right, I want you guys to watch something here. You can put this in your notes and then I'm going to show you something with it. All right, that would be height. Would you agree? Now, if I can capture it. Okay, so everybody watch the screen. Everybody ready? Look, this height, would you agree this is all the same distance? The length is the same. You know what? It could even be out here. Or it could be way out here as well, right? It would all be the same amount. It's the distance between the two parallel bases. A lot of times they'll stick it right there at the vertex. Does it have to go to a vertex? No. As long as it's the distance, a perpendicular distance between the parallel sides. Got it? Okay, if you get that, then the rest is figuring out how to use the formula. Here's a very unique trapezoid, and I gave it to you on purpose. Where would you put base 1 and base 2? Where would you put the height? Go ahead and try to do it. You can always cross it out if you get it wrong. Which two sides would you label base 1, base 2? Where would you put h? You got to do it in respect to what I just taught you. You got to hurry here. I got about 10 minutes left. All right, I don't know if you had enough time, but hey, you could call that base 1 or base 2. This one would be the other one, right? And height is always the perpendicular distance between the two parallel bases, right? Aren't these two lines here and here, right? This line and that line, aren't they parallel? So the parallel sides have to be the bases. How many got that right? Not enough of you. Do you understand now? Do you understand why those two sides are base 1 and base 2 and the other's the height? Remember, the bases are always the parallel sides. All right, let's get to a few problems. There's the formula up above for you. This is a common problem. All right, for time's sake, being the formula is right up above this one, we'll just use it. So a half is a half. Somebody tell me what to put in for base 1. Raise your hand. Tell me what to put in for base 1. Raquel. Okay. Sounds good. 6 inches for base 1. Adam, base 2. 10 inches, base 2. Somebody raise your hand. Give me the height. Gabe. 3 inches. Again, if you guys will include your units. Hey, somebody tell me with grouping symbols, remember the order of operations, right? Go inside of parentheses first. Now look, I hope we can all add 6 and 10. I hope. 6 inches and 10 more inches is 16 inches. It's not inches squared, right? We didn't multiply, we added. 6 of them and 10 more of them is 16 of them inches. And then we're still times the 3 inches outside. That's how your work should look. From here on out, you can use your calculator, right? But those are the steps I should see. I should see the formula. I should see your first substitution. I should see what you get for the parentheses. And then that's all you need to show me. Use your calculator, get the answer. So what's a half of 16? 8 times 3. And what are our units? Inches what? Inches times inches is inches squared. We're multiplying there. Right? 24 square inches or inches squared. Make sense? Hope so. Hope so. All right. Second problem. Now I got more values there, right? A little bit more interesting. All right. Time's sake, really quick here. Area trap. 1/2 parentheses b sub 1 plus b sub 2 close parentheses h. It's the formula, right? You got it right up above on your page. All right, somebody raise your hand and tell me where b1 and b2 are. John?
6 and 11.
Awesome, right? John saw the parallel sides. That's b1, b2. So I'll come below. 6 is that feet. 6 feet. 11 feet. That's my parentheses. Still got my half. And height then. Last question. Ashton? It is the 5 feet, right? The perpendicular one between the 2 parallel sides, right? Not the 7. 7's not perpendicular. Agreed? So we got to use the perpendicular one. Okay. Again, just add up in the parentheses first. That's 17. And on this one, you're just going to use your calculator. And what do you use for the half? 0.5. Just punch it out. 0.5 times 17 times 5. And somebody tell me what you get. 42.5 square feet. My feet are not square. Well, that's a lot of stink, I got to tell you. Stink squared. Square feet. Squaring. Don't feet stink? All right. Okay, be careful. To find the base, sometimes they'll ask you to find the base or height. Use the appropriate formula and solve. Now we're back to a triangle problem, right? I'm going to get rid of this so I can go higher. So we're back to a triangle formula. So do you agree area of a triangle equals 1/2 BH? Do you agree? And we are looking for the height, yes? So which side is the base? Say it if you know it. Give the number.
25.
The 25, because again, the height has to be perpendicular to the base. So here's how you do a problem like this. We've done things similar. Put in the 30 inches squared for your area, right? Keep your half as a half. Put in 25 for your base times the h, the variable. Agreed? All right, for you guys, the easiest way to finish this one, now if the half divide it into the 25, that would be easy, right? And if you want, you could even use 12.5 if you want. But let me show it to you if you left it as a fraction. Is that any big deal that it's a 25 over 2? How would we finish this? Somebody tell me what to do. Wyatt? No, we got to finish. We're going to isolate the variable. John? They told us it. They said the area was 30 inches squared. How do we get to h? Alexandra? Absolutely. Multiply by the reciprocal. Multiply this by 2 over 25, right? Don't forget, you guys get used to dividing as the shortcut, but don't forget it's a shortcut to multiplying by the reciprocal. Now just finish off on your calculator. 2 times 30 divided by 25. 2 times 30 divided by 25. 2 times 30, that should be inches, by the way. Inches, inches. Scribbled out inches. I'm trying to go too fast. So anybody got it? 60 divided by 25 is, Nick? Say it again. And it is inches, right? Because what happens in our units? Inches squared are inches times inches. One of them divide out, leaving you inches. 2 times 30 is 60. 60 divided by 25 is 2.4. Now again, if that bothers you, it shouldn't. We've multiplied by reciprocals. You can do 25 divided by 2 is 12.5. Jordan, if I got a minute, you can ask me, but I got to get to this last problem. I just told you I got to get to this last problem. So if I have a minute later, you can ask me, but I got to get to this last problem. Find the area that is shaded. This is a tricky question. Find the area that is shaded. All right, this problem is area total equals area of a trapezoid, the big shape, minus the area of the triangle. It's a tricky problem. So here's how you would finish a problem like this. Next thing you'd put in your formulas. Trapezoid 1/2 base 1 plus base 2 times height minus area of a triangle 1/2 base times height. I know the bell's going to ring, but listen for a second. Is the base, let's do it height. Is the height of the trapezoid the same as the height of the triangle? No. Here's the height of the trapezoid from here to here. What's that value? From here to here. 3 and 3 is 6. What's the value of the height of the triangle? 3. Be careful. Use the right values. You'll have problems like that. You got the homework at the end of the page? You are dismissed.